The universe operates within an intricate web of interconnected systems, all of which strive for a state of homeostatic balance. However, in the realm of complex systems, traditional models of causation often fall short when it comes to explaining phenomena that don't adhere to linear, unidirectional cause and effect relationships. Such models typically assume that causes precede effects in a straightforward, time-bound sequence. However, both natural and human-made systems frequently exhibit behaviors where effects influence their own causes, or where future events seem to exert influence over past or present states. This prompts the need for a more nuanced approach to understanding causality, one that accommodates the intricacies of nonlinear and retrospective dynamics. The context of homeostasis provides this balance through triadic systems, specific logical patterns that can be understood through a framework of relationships between three variables. These triads represent fundamental modes of interaction, where factors within a system must either all exist together or all be absent, ensuring that the system maintains its equilibrium. At the core of our framework is the idea that all phenomena, whether physical, biological, or cognitive, can be understood as participating in one of several types of triadic relationships. Each triad represents a different mode of interaction among three elements, and these interactions govern the behavior of the system as a whole. By analyzing these triadic relationships, we can better understand the underlying principles that guide the dynamics of complex systems. To capture these more complex interactions, we explore two specific types of triadic relationships within systems: nonlinear causation and retrospective causation. Nonlinear causation describes a scenario where future events are necessary for preceding states to occur. A is a required condition for C, C is required for B, and the absence of A leading to the absence of B. This introduces an anticipatory effect, where the mere possibility of a future event shapes the present, bending the traditional timeline of cause and effect. In essence, the future reaches back to influence the present, creating a feedback loop where outcomes appear to arise from conditions that have yet to fully materialize. Retrospective analysis goes a step further by examining the negations, positing that the future not only influences but is indispensable for certain earlier states. In this model, the future event organizes and structures the present or past, suggesting a form of retroactive influence where time seems to flow backward, linking outcomes to causes that are temporally displaced. It might at first seem easy to dismiss as a trick of logic, to say that while logical dependencies might allow such forms of balance in a system on paper, real systems cannot work this way. Which is why we turn now to experimental evidence of a specific case. To illustrate these abstract concepts, we turn to the work of Rupert Sheldrake, a British biologist known for his controversial research on the nature of consciousness and morphic fields. Morphic fields are a concept advanced to help explain otherwise inexplicably connected events. In one of his key experiments, Sheldrake explored the possibility that individuals might unconsciously anticipate emotionally charged images before they are presented to them. In this experiment, participants were shown a sequence of images, some emotionally neutral, others highly charged. Their physiological responses, such as changes in skin conductance or heart rate, were monitored to detect any anticipatory reactions. Remarkably, the data suggested that participants exhibited measurable physiological changes 5 seconds before the emotionally charged images were shown, but not before neutral images. While some anticipatory excitement was expected and random, all tests showed statistically significant increases in anticipatory response prior to the display of a charged image. Crucially, the computer used did not even decide which type of image to display in advance, so the physiological responses could not be attributed to any contemporaneous perception of another type. This finding challenges conventional models of causality and hints at nonlinear and retrospective dynamics. Nonlinear causation posits that future events can have a determining influence on preceding states. In Rupert Sheldrake's Precognitive Experiments, this model offers a compelling framework for understanding how participants seem to anticipate emotionally charged images before they are shown. Here's how we can break down the sequence. A. The initiation of the experiment, where a signal is given to the participant that an image will soon be displayed. This decision, whether an image will be shown and whether it will be emotionally charged or neutral, is made randomly and only immediately before the image is presented. B. The participant's premonitory emotional response, detected before the image is actually displayed. C. The emotional response when the image is finally shown, which may be either emotionally charged or neutral. The sequence in Sheldrake's experiment can be understood as follows. The initiation of the experiment, A, naturally leads to the eventual presentation of the image, C. The participant is aware that an image will soon be displayed, setting the stage for their emotional response. The nature of the future event, C, whether the image is emotionally charged or neutral, determines the premonitory emotional response, B. This implies that the future event, C, is already influencing the participant's emotional state before it occurs. In this framework, B, the anticipatory emotional response, is directly shaped by C, the nature of the image that will be shown. This creates a nonlinear relationship where the future event, C, resonates backward in time, affecting the participant's emotional state, B, even before the image is presented. The anticipation of the emotionally charged image, C, influences the participant's physiological and emotional state, demonstrating how future outcomes can shape present conditions. Retrospective causation delves deeper into the idea that the future not only influences, but is necessary for certain prior states to occur. In the context of Sheldrake's experiment, if there is no premonitory emotional response, not B, it suggests that no emotionally charged image, not C, is forthcoming. The absence of the emotional response before the image is displayed indicates that the participant's system doesn't anticipate a significant event. Here, the future event, C, is seen as essential for the earlier anticipatory change, A. The future not only influences but actually organizes and prepares the system in advance. This retrospective causation implies that the presentation of the emotionally charged image in the future ensures that the participant's physiological system is primed in the present. The system seems to know what's coming and adjusts itself accordingly. To understand how these complex causal relationships might operate, we can look to Sheldrake's broader theory of morphic resonance. According to Sheldrake, morphic fields are non-material fields that shape the development and behavior of organisms and systems. These fields carry information across time and space, creating connections between past, present, and future events. Morphic fields allow for the transfer of information without direct physical interaction, suggesting that patterns of influence can resonate across time and space. In the context of Sheldrake's Precognitive Experiments, morphic fields provide a plausible mechanism for explaining how future events might influence prior states. The nonlinear model can be seen as specific manifestations of how morphic fields operate within particular contexts. In nonlinear causation, the morphic field could be envisioned as a medium through which the future event, the emotionally charged image, resonates with and shapes the present physiological response. The future event influences the morphic field, which then organizes the participant's present state, preparing them for what is to come. This resonance effect transcends the usual boundaries of time, creating a scenario where the future reaches back to shape the present. In retrospective causation, the morphic field takes on a retroactive role, where the future event, the emotionally charged image, not only influences, but is necessary for the earlier anticipatory state. The field reaches back in time, organizing and structuring the present in preparation for the future event. This retrospective causation suggests that the future is not merely a consequence of the present, but plays an active role in shaping it. Morphic fields provide an excellent conceptual tool for understanding those forces for which we have not yet identified a measurable mechanism. But they are simply an explanatory visualization for our triadic framework, a set of equations demonstrating how three objects can maintain a positive or negative state through mutual influence. The universality of our framework stems from its foundational logic. All systems exist in a homeostatic balance, governed by interdependent relationships that can be understood through one or another of our triads. By applying our models without assumptions, we can identify statistically significant relationships that align with the patterns our triads describe. This method allows us to uncover the hidden structures that maintain balance within any system, regardless of its specific nature. Our equations are concerned only with logical dependency and necessary requirements. They account for not just temporal nonlinearity, but simultaneous action and non-locality at every level of existence. The triadic framework is designed to be universally applicable across natural systems, grounded in a first principles approach. By not presupposing the existence of specific fields or forces, we allow the framework to be adaptable, capable of identifying and analyzing variables purely based on their observed relationships. This flexibility is key to understanding the diverse range of systems in the natural world, from biological processes to physical phenomena and beyond. Ultimately, the extensibility of our triadic framework offers a new lens through which we can view the natural world. By approaching each system with an open mind and a reliance on first principles, we can uncover the fundamental relationships that govern the universe, leading to a deeper and more unified understanding of the interconnectedness of all things. I encourage you to subscribe and explore this channel. We have more than 2,000 videos exploring the application of triadic models to specific real-world contexts, as well as examining how these patterns have been more systematically applied to create the philosophical, scientific, and religious frameworks that dominate the world today. Remember, the triads are not just an explanatory tool. By understanding the connections underlying our reality, you too can create the conditions for positive change.